Okay, so let's talk about dividing radicals. And dividing radicals and multiplying radicals are really similar. Just like when you multiplied radicals, you multiply the things inside radicals together and multiply the things outside of radicals together. In dividing, you divide things in radicals together and you divide things outside of radicals together. So in this first one, I would divide radical 30 divided by radical 5, and this would give me radical 6. So they're both in radicals, and I can divide them. This one, because this 2 is outside the radical, when I go to divide this, I can only do radical 2 divided by radical 20. And radical 2 divided by radical 20 would give me 10, so I get 2 radical 10. Okay. Let's try a couple more of these, and I'm going to write these different way. Okay, so this is just like the last problem. The other way we could write this is 7 radical 48 divided by 3 radical 6. Doesn't matter how you write them. I'm going to start writing them more as fractions because it helps me think about what to do. So then we narrow in. First thing I'm going to do is try to divide 7 by 3. And 7 is not divisible by 3, so I'm just going to leave it. Say that's 7 over 3. Then we're going to divide what's in radicals together. Well, I can divide 48 by 6, and if I divide 48 by 6, I end up with 8. Now with this problem, I'm not quite done, and the reason I'm not quite done is because this radical 8 could be simplified. So it could be broken up into 4 and 2, which would end up giving me 14 radical 2 over 3, because the square root of 4 is 2, and 7 times 2 gives me 14. So that's the basic idea behind doing this as fractions. Most of the things we will see as fractions, so I'm going to give you a couple more examples of this. Okay, so let's try this one. This one even gets a little bit more complicated. Our first step is we are going to try to divide as much as we can. Now we know we can't do 14 divided by 8, but I could simplify this fraction because both these things can be simplified by 2. So that would give me 2 over 9. Same thing with the 7s. I know I can't divide these things kind of outright, but I could divide both these things by 7, which would give me the square root of 1 and the square root of 2. And again, see how the whole numbers are different than the radicals. They don't really mix. Now we can simplify even further because I know what the square root of 1 is. It's 1, and then 1 times 2 would give me 2. So this thing would be 2 over 9 radical 2. Now, I would not accept this answer. And the reason I would not accept this answer is because of this big issue right here. On the bottom, we have a radical. And we can't have a radical on the bottom. So after you divide, if you end up with a radical on the bottom, what you need to do is you need to rationalize it. If you remember how we rationalized it before, we multiply the top and the bottom by radical 2, which would give me 2 radical 2 over 9 radical 4, which that would be equivalent to 2 radical 2 over 18. Well, then I'm not even quite done yet, because we made the problem become a little bit different by having something new that this number and this number can kind of divide with, which would divide by 2, and I'd get 1 radical 2 over 9. So these problems can get a little bit lengthy when you can simplify lots of stuff. Let's try another one. Okay, so we got a lot of stuff going on here. So this one looks really confusing to divide, but the nice part is they're both in the radicals, so we can kind of divide this like normal. I'm going to divide 36 and 12 first, and that would give me radical 3. Now we're going to divide this, and if you remember how to divide exponents before, dividing exponents acts like subtraction. So a to the 4th divided by a to the, well, if they don't give me a number, that's to the 1st. would just be a to the third, and it would have a radical over it. B to the third and b to the second would just be b. And c to the seventh and c to the third would just give me c to the fourth. Now, again, everything canceled off the bottom, but we still need to simplify as much as we can. C to the third is just, or radical 3 is just radical 3. A to the third is really a squared, and a. Radical b is just radical b. And c to the second is really c to the second and c to the second. Now we'll try to reduce this as much as possible. That one stays the same. Well, those cancel, and that just gives me a. That's a radical a. That's a radical b. Those cancel, and I get c. Those cancel, and I get c. Now I'm just going to rearrange everything to make it a little bit nicer. So I'm going to get a c squared radical 3ab. And that would be my final answer. Let's do one more problem that's similar to this, but we're going to make it pretty complicated. So we're going to have a lot of steps in it. If you get stuck on any of the steps, please write down which steps you get stuck on and kind of highlight them so we can go over them together. Okay, so even though this problem looks like it might be a little bit simpler, it's actually going to be more difficult. So we're going to try to figure out what this would be. So here's the first thing we're going to do. We have this 9 and this 18, and we know that they can reduce. And we would, when we reduce them, 9 divided by 9 is 1, and it kind of goes away. And then we divide this by 9, and we get 2. So we get radical 2 on the bottom here. The 8 of the first and 8 of the fourth will subtract, and we'll have 8 of the third on the bottom. It still has a square root. And then b to the third and b to the second will just give you a radical b squared on the top when you subtract those. And now we have to deal with this thing. Well, this thing is, we can make a little bit nicer by dealing with some square roots. So let's deal with some square roots. We know that b squared would just give me b. We know this is radical 2, and this is radical a squared and radical a. So that's what the radical a to the third becomes. Those would cancel. And so if we really want to write this nice, we'd get b a radical 2a. Now here's the issue. We still have a square root on the bottom. And again, anytime you have this square root on the bottom, you have to get rid of it. Whoops. I lost my a. So because you got to get rid of it, what we're going to do is we're going to multiply the top and bottom by that. So times both the top and bottom by radical 2a. And what I'm going to find is that I get b radical 2a over, well, 2 times 2 gives me 4, and a times a gives me a squared. So this is 4a squared. Well, then how that breaks down is that becomes 2. So this is going to become 2. And this right here is just going to become a. So then when we combine everything on the bottom, oops, I ran out of room there. When we combine everything on the bottom, we're going to get b radical 2a over a squared. And we got a 2. And that would be it. Okay. So again, your goal. Divide as much as you can inside the square roots and the numbers outside the square roots. After you do that, you have to look at your final answer. If you have a radical on the bottom, you can't leave it. So see here, we had a radical on the bottom, we couldn't leave it. We got to multiply the top and bottom by that. And then we simplify as much as possible. These problems will be a little bit tricky, but I think you'll be able to do them. You just have to be very, very careful.